So this video is on set notation, and the notation covered in this video will be used almost every day in your higher education. It's incredibly simple to understand and extremely useful, so if you can use it fluently before going to university, it will make your life a lot easier. So in mathematics, there are different sets of numbers which you may have already come across. The first of these sets that I'm going to go through today is known as the natural numbers, which is denoted by this symbol, n. The natural numbers are all the positive integers, so n equals 1, 2, 3, 4, all the way up to infinity. The next set is the set of integers, denoted by this symbol z. So z is all of the integers, positive and negative, going from minus infinity all the way up to infinity. The next set is the rational numbers, denoted by this symbol q. A rational number is any number that can be put into a fraction. So, for example, a half is rational. Whole numbers are also rational. For example, 3 can be written as 12/4. However, numbers like pi and √2 are irrational as you cannot put them into a fraction. So here are a few examples. Really, any fraction that comes into your mind will be in this set. There are infinitely many rational numbers. The next and final set is the set of real numbers, denoted by this symbol r. Real numbers are any numbers that are not imaginary. If you haven't covered imaginary numbers, to put it simply, it is the square root of a negative number. As we know, this doesn't actually exist. The numbers are known as imaginary, but any other number you can think of is in this set. Positive and negative, whole numbers, rational numbers. Here are a few examples. You can notice √2 and pi, as they are irrational, they are in the set of real numbers. So as you may have noticed, all of the larger sets contain the smaller sets. So take this to be our set of real numbers r. Inside our real numbers are the rational numbers, as all rational numbers are real numbers. Inside of our rational numbers are our integers, as all integers are rational numbers. And inside our integers are natural numbers, as all natural numbers are integers. So this is known as subsets, which is denoted by this symbol here. So as all of the members of the natural numbers are also members of the integers, we say that n is a subset of z, and you write it like this. And then as all integers are rational numbers, we can say z is a subset of q. And as all rational numbers are real numbers, we say q is a subset of r. So notice how, as all natural numbers are integers and all integers are rational numbers, then all natural numbers will also be rational numbers. So we write n is a subset of q. Also for the integers, as all integers are rational numbers and all rational numbers are real numbers, we write z is a subset of r. So this can also be written as a list. So this here means n is a subset of z, which is a subset of q, which is a subset of r. So these are all predetermined sets. However, there are also sets used in questions and proofs that can be given to you, or you could make up yourself. So, for example, say you wanted a set to be known as x1 and have only positive multiples of 4. Then you'd have x1 equals 4, 8, 12, etc. all the way to infinity. And then you could have another set, say x2, to be all the positive multiples of 8. Then clearly, as we know, all multiples of 8 are also multiples of 4. We know that all members of x2 will also be members of x1. So we can say that x2 is a subset of x1. We could have another set, which is y, which could denote all even numbers. So y goes from minus infinity up to infinity, listing all of the even numbers. So this symbol here means is a member of. So that is how we write down if we know that a number is a member of another set. So for example, as 8 is a positive integer, we know it is in the set of natural numbers. So we say 8 is a member of the set of natural numbers. and we write that down like this. So this is great for speed purposes in proof and lectures, so you don't spend ages writing down loads of words. It also works for unknown numbers. For example, if we knew n was rational, we know that n is a member of the rational set of numbers, and so n is a member of Q. If you had a number x, which you knew was a positive multiple of 4, using our set that we created in the last slide, we know that x is a member of x1. So you can find all of these symbols on our glossary page for revision purposes. You can always rewind the video, rewatch it if you need to, but as it is relatively simple, hopefully you won't need too much revision on it.